afternoon, everybody, and welcome to this part of the program. And what I'd like to do is to talk about the view from San Diego on what advances and breakthroughs in robots are likely to be. And I'm going to merge that a little bit with a theme called Trillion Sensor Technology. And I'd like to introduce myself. I'm Al Pisano, the Dean of Engineering at UC San Diego, and I've just completed about a year and 2 or 3 months in the job. So I have a series of 5 very simple sentences, very simple messages I want to communicate to you, and I will give you each sentence and then a supporting slide to describe what it is. And I'm hoping, as a result, we generate some significant conversation. So let me just go to the first provocative statement, and then when we go into the panel session after me, I think we're going to hear a lot of pro and con from the panelists as to some of these statements. So the first bold assertion I'm going to make is that robotic systems that actually understand the context in which they operate are coming, and indeed, thank you, are coming, and they're going to be here soon. Now that may be an outsized statement to make. Let me offer something about that. So just a few days ago, on October 10th, at UC San Diego, we hosted the first ever international conference on contextual robotic technologies, where we brought in these 8 international leaders to tell us what their visions were. And indeed, we are getting stories of robotic systems that really do understand their context. So if we go to the upper left and look at Chris Anderson, the CEO of 3D Robotics, which by one measure is the largest drone manufacturing company in the world based on number of products shipped. You may not know that in every one of those drones, there's a GPS system which understands where the drone is and understands the local no-fly zones, like high-tension cables and airports. And if you, as an over-enthusiastic drone operator, try to drive the drone into that no-fly region, the drone will ignore all future inputs from the joysticks and basically retrace its steps and go all the way back to the launch point. Now, if you are a drone operator and your drone goes all the way back to the launch point, that's actually a big punishment because it just blew all the battery for the mission life coming home and resting. And now you got to change the battery out and go through a whole bunch of other things to get yourself ready for the mission. So there's an example of a drone basically disciplining its quote-unquote master. You know, imagine the dog hitting you with a rolled-up piece of newspaper instead of you hitting the dog, right? That is already here. That is already here. And innovations like that may be part of the issue of dealing with the FAA and the regulations, and one of the previous speakers on the panel mentioned those. If you look at the middle top view, Rodney Brooks, the CTO of, I can't read my own writing at that distance, and I apologize, Rethink Robotics, of course, and of course the product for that company is Baxter. Now, Baxter is a robot that mimics human motion on low-speed assembly lines. That machine is designed not to bump into people. It's designed to be careful. It understands that it is the 600-pound bull in the china shop, and it doesn't break the china. So this is a robot that has the beginnings now of understanding its context. The context there is, yeah, I have a job to do, but the number one job is not to hurt the people on either side of me because I'm standing next to the workers doing one of the functions that's inconvenient or dangerous for them to do. And if you go through all the rest of the talks, there is always a component of that there. So you're seeing an acceleration of this trend, and whenever you see that trend accelerate, whenever you see instances appear, then you sort of know that is coming. The second point I want to make, aside from giving an unashamed plug for my own school, is that we're not the only ones who see this trend. We're forming an institute for contextual robotic systems. We have the first faculty member hired. We have 4 more that will come on board in the next 6 months. The real point is that other academic institutions have glommed onto this big time. And some of them have representatives on this panel, and I'm hoping that you ask them probing questions about this. The supporting data is that if you go to a school that does not yet have an institute and is only building it, as we are, I can get 60 faculty to show up to an institute planning session with a simple email. And these faculty come from Cog-Sci and Bio, where they're trying to map over how humans learn into how machines should learn. And you may have heard of the Cow Brain Project, right? Mapping and understanding the brain, the federal investments in that. Our campus was one of the drivers to make that happen. And indeed, there's a large number of people who are busy mapping brains. And now granted, you're going to be mapping a lot of fruit fly and mouse brains before you're mapping human brains. But the brain mapping process is going. And so everyone is now getting very excited about how you look at understanding context, not in an arithmetic machine or a von Neumann machine way. And when people are making big shifts in the paradigm like that, then you know that they're getting around the obstacles that have stopped us from doing it so far. Some of the panelists here that you'll hear after my keynote can address these topics as well or better than me, but I'll just offer that you're going to see an acceleration of the robot applications, not just for air, but also undersea, in harsh environments, and in fact in confined spaces where humans can't go. And what is not on this slide is a burgeoning market, a soon-to-emerge market in household or consumer robotics. Now, the household or consumer robotics are not going to look like anthropomorphic machines. It's not going to be Robbie the robot transported out from 1950 to the year 2020. What you're going to see is automated agents who understand the context of the situation and who will contradict your command if it's the right thing to do. Now, that's going to open a whole Pandora's box of issues. And indeed, there are several universities, mine included, which have started programs in robotic morality. What are the moral rules for machines? And some of the speakers earlier had talked about machines and humans in tight confines. And indeed, you can define a set of kinematic or dynamic rules so that machines don't bump into you. But you know, if a machine stands there and watches you fall down a flight of stairs when the machine had an opportunity to avert that, how long will it be before your expectation is that you should have been given a signal? And under what circumstances should you give that signal or not? So a number of research communities are gearing up to look at that. And indeed, the vision I'm giving here is that it's not going to be just about the technology. You're going to see policy, ethics, a whole bunch of litigation rules, a whole bunch of other things tied into this. It's only going to accelerate.